All right, guys. Let us start with the today's session. Okay. So, good evening, everyone. Welcome to day 3. Right. So let us discuss today about logistic regression and some practical part. Okay. So I've given the drive link. I think that it will be shared in the chat. Okay. So maybe I'll also share one link here. Just give me a minute. I can download this. Okay. And anyway, we'll discuss little conceptual about what is logistic regression and all, and then we'll take it forward on how to implement that. And the most important part, apart from the discussion of the concept and practical part, let us also discuss some of the interview questions. What can be expected till the concepts what will be discovered, discussed today. So, with the basics of, machine learning, data pre-processing and all, then linear and logistic regression. So we'll cover this aspects in, today's interview questions preparation as well, right? So let me, without any further delay, let me share my screen and let me start the session. So in the middle, I just wanted to tell you in the middle I'll take up some questions. Okay, so because we have to cover the concept as well. So in the middle I'll give a couple of minutes, maybe based on the time what we have, because we have to cover in the given time constraint. So in the middle I'll just take up some questions. You can post your questions in the chat. Even though it's in the middle, it's fine. I will take up once I take a time out of what I'm training. In that we can do the questions part. Fine. So let us go ahead. Let me share my screen. Yeah. So I think you can see. Okay, great. Fine. So now let us start. What is logistic regression, right? So we have discussed one particular concept, or I can say one supervised learning algorithm, right? So which is called as the linear regression, right? And linear regression is one such algorithm which is actually uh, you know used in machine learning for predicting a numerical value, right? Or a continuous variable. So now, what if we have any classifier, right? So something which is in the form of a classifier, or how do we proceed with that, right? Now, for that, we have certain algorithms, like for example, decision tree, random forest, right? So for that kind of, problems, we have, one strong solution, which is the logistic regression, right? Many people actually take logistic regression very lightly, actually, right? But I don't think, it's a kind of algorithm, with my, experience as well, when implementing projects and all, logistic regression is one such area where the the implementation part, right, or the use cases or applications are very high. Okay, so it is not an algorithm to be taken lightly, and so it's a very strong algorithm in my point of view when you go for machine learning. So now let us understand what is this logistic regression first. So what is this logistic regression is? It is an algorithm where it is used to predict the classifiers, right? So not like a numerical value. Now let us see one small picture. Okay, so now here you can see that there are two outcomes for the model what we are seeing here, right? You can see a penguin and it has two, I can say two outcomes, right? Or I can say it's behavior of a penguin on certain scenarios. Either it is happy or sad. Here, if you see, we cannot use a linear regression model. Why we cannot use? Because the outcome is not a numerical value. So here you can see there is no outcome of a numerical value. In that kind of scenario, we have to use models which can deal with classifiers, okay, or classification problems. So here you can see that, it is either happy or sad. So however inputs we might have. So here you can see x1, x2, x3, and so on, right? So we may have 20 variables, we might have 25 variables, we might have some 35 variables. That is irrespective. Or we may have only three variables, how I mentioned here. So irrespective of how many variables are or input variables or independent variables, the outcome variable can only take two outcomes, right? One is happy or sad. So using the model, right, in this case, we are discussing about a logistic regression. So when we talk about this model, what the logistic regression does is it takes the input data and it is trying to predict whether our penguin is happy or sad. So here we may have weights and all those things, right? We apply many things. When we talk about a model, there are many aspects or parameters when it comes to a model. So we talk about multiple things, but the important thing is the target variable or the outcome variable or the dependent variable. So now let us move forward. Let us try and understand, right, what more we can learn about logistic regression. So, so it's a very easy algorithm to implement also and very easy to understand also, right? So now we'll see the different types of logistic regression. So, something has only two outcomes, right? That becomes a binary logistic regression. Very simple. Yes or a no, or a true or a false, or a zero or one. Something which has only two outcomes becomes a binary logistic regression model. Right. So for example, I've taken a very small example, whether the patient has the disease, yes or no, right? You can, if somebody asks you, do you have a disease? You will, a particular disease, you will say yes or a no, right? You cannot say maybe, right? 100%, 80%, you cannot measure a disease, right? So you can only say yes or no scenario. So in that case, that becomes a classifier, right? Or here you can see it is a binary classification, right? So whether the person has repaid the loan or not. So either the person has paid the loan or not. There is only two outcomes, no? So for example, sir, he is unable to pay, he has some problem. So it is a no, right? So simple, something which can be classified into yes or no becomes a binary. Something which can be or which cannot be only classified into two, it has more. For example, like a customer rating. Very good example to understand multinomial logistic regression is the customer rating, right? So if you buy a product from Flipkart, Amazon, the rating, the stars what you get to rate, right? They are five, right? So there are five outcomes. So in this five, there are five classifiers, whether you rate it 1 star, 2 star, 3 star, 4 star, 5 star. So it is more than two. Something which is more than two, right? So two becomes a binary classification. Okay. So more than two becomes multinomial, whether it might be 3, 4, 5, and so on. So next is the ordinal. So ordinal is very important in a few circumstances. For example, like a severity of a disease. Best example, is you would have heard about cancer, right? So cancer, there is level 1, level 2, level 3, level 4, right? A person cannot jump directly from level 1 to level 4, right? So something which goes in an order, that is why it is called as an ordinal. So for example, customer satisfaction. So you cannot say customer is satisfied, directly he goes from 3 to 4. So, the customer goes, the satisfaction level will be going in an order. Something which goes in an order is basically called as a ordinal. So the same goes for the logistic regression also. So ordinal logistic regression. So the tricky part or the very important thing, I think by this time you would have understood what is the need for using the logistic regression when we already have linear regression. So why do we use? Because the outcome variable is not a continuous variable. It is a classifier, right? So in that scenario, right, we use the logistic regression part. Okay. And even though the input variables or the independent variables might be the independent variables might be numerical values, but the outcome variable or the target variable might be a classifier, right? So then at that particular point, we have to use the logistic regression. We cannot go with the linear regression model. So here is a small example where how the logistic regression actually is. So usually when we build a model, right, we try to take the threshold value as 0.5. For example, here is a very small example where you can see, right, you can see a straight line. So sir, this is a straight line. So this becomes a linear regression. Yes, I'll come to that. So for example, if you have to classify a data point, whether it is yes or no, you have something called as a threshold value in logistic regression. So something is above that threshold value, it becomes yes, right? Something is below that threshold value, it becomes no. So in this case, the person is having, that particular disease, malignant tumor or not. For example, if the data point falls below that particular line, that blue line, right, it becomes no case. And if it falls above, it becomes a yes case. But now the little problem comes is if the data points are coming like this, right? So then it is very difficult to build a particular, right, a particular regression line, right, which is in the form of a straight line. So we have to move the, class threshold value, right? So from the blue line, we have to change it to the yellow line or, some other line. So, so how do you, keep on changing that? So that is the problem here. So we cannot keep on changing that threshold value. We cannot construct some 3 or 4 threshold values, right? How do you classify? It is not possible, right? So in this case, something, you were not able to classify because the threshold values are, keep on changing and you have multiple threshold values. That is in where you have something called as a logistic regression. So basically to overcome this problem, we have something called as a logistic regression, which is in the form of a S-shaped curve. So let me, take you to that particular curve. Yeah, first I'll show that, then I'll come there. So here you can see, a diagram where it shows, right? Now you can see that the points, more points are covered by this logistic regression curve, right? So it is basically in the form of a S-shaped curve. Okay, so linear regression doesn't help you to cover all the data points. So let me go back. Yeah, fine. So now let us discuss a few assumptions why we use a logistic regression. So particularly, the scenario where we use the logistic regression, because we have a something called as a yes or a no or a 1 or 0 or true or a false scenarios. So now the data specific assumptions are the dependent variable should not have, for example, if you're talking about a binary, you should not have more than 2 classifiers or 2 outcomes or 2 categories. So, and the observations also should be independent of each other. So, this is very important when you want to classify or when you want to build a logistic model. So then comes the how do you build the relationship between the variables? So how do you build the relationship is, since the logistic regression is not a linear function. So if something is a linear, we would have used, we would have used linear regression. Now, why we want to use logistic regression? That is why we use the logit function, which is the log odds, right? So log odds function. So now next important thing is the multicollinearity. So, multicollinearity, we have already, when we have discussed the basics, we have gone through. So what is basically multicollinearity is not having high correlation between the independent variables. So next is absence of outliers. So when you want to build a logistic regression model, the most important thing for you to verify that the data is not having outliers and the sample size should be a adequate size. So these are some of the assumptions and things which are very much required when you want to build a logistic model. So how does it work? So it works in the same way how the other machine learning algorithms also work. So preparation of data, then training the model. So first of all, understanding the business problem. How, okay, now we understood that we need a certain data where our outcome, whether the person will buy the product or not. So in this case, you can use the logistic regression. So if you are, you want to analyze a market for a particular product which you want to build, and you want to sell it in the market. So you want to collect the data. You have a business problem where you want to sell a particular product. So whether your product with this kind of product, what you want to launch in the market wants to be successful or not. You want to suit make some data analysis, or you want to build a model and check. So for this, you can use the logistic model. Why? Because you can, you will be sure that the data collected, but your outcome is definitely whether the person will buy this product or not, or which kind of person will actually buy this product. So to understand this, you can use the logistic regression problem or logistic regression algorithm. So here, once the data is prepared and you have, you have once you have, have the business problem, then the data is collected, data preparation, cleaning part, pre-processing, everything is done. So we come to the next part where we train the model, then we evaluate, testing the model is basically evaluation, and then we try to make the predictions as well. So coming to the function, okay, so no need to remember any formulas on logistic regression, but it is basically built upon the linear linear function, which is beta naught plus beta 1x. So from the function beta naught plus beta 1x, which is the straight line equation, from there we try to apply the logarithm part, and then we try to apply the function, and then we try to we do a little differentiation and all those things in order to get the formula. Okay, so you can just remember that this is how it is calculated. Okay, no need to remember, because nowhere you are going to use the formulas when it comes to the logistic. You directly build the model and you will get the final sigmoid function. Okay, so here you can see the sigmoid function. It is basically 1 by 1 plus e power minus x. So, or you can say minus y. In that y place, you have the beta naught plus beta 1x. So that function is called as a sigmoid function. Just give me a minute. Right. So that function is basically called as a sigmoid function. So it is in the form of a S-shaped curve. Now, so I think you would have already understood. Maybe I can skip this, where you can understand that what is the difference between a linear and a logistic. So obviously, when you are building something which is non-linear, particularly, and the outcome is also a categorical outcome, or you can say categorizer, right? Or a something which can be, form not a numerical value. Maybe you can remember like this in a very simple term, right? Or a classifier, as I told you already. Fine. So I'll just skip this. Right. We'll go to the key properties. This is very important. So in the key properties, we have something called as a sigmoid function that we have discussed. And here, very important is to understand that people often get confused. This key point also I have actually taken up. The function, or you can say the input variables, all the input variables, for example, are independent variables. All the variables in the independent criteria might be numerical values also. So you might feel you want to build a particular straight line and you want to predict, but you should actually build a logistic model in order to predict the outcome, because even though you are having very rare, as I already told you, when you remember when you were dealing the linear regression, I've already mentioned that very rarely you can see that the data is in the linear form. So in this case, even though the data is in a linear form, right? For example, by any chance, since the outcome is a classifier, you cannot use a linear model. So, it is very hard to predict using the linear model because we are not predicting any numerical value. This is one very important which has to be understood. Okay. So basic assumptions and all, and yeah, and probabilities, and one more thing. So, sir, I showed you, when one picture where you can see that the threshold value is basically 0.5. So you told that you have a 0.5. So threshold value is basically assumed to be 0.5, but but in reality, right? Sometimes we need to push the threshold value up or the threshold value down. So it is not very likely, like if you say because the entire concept of logistic regression depends upon the concept of probability. It is a sheer probability. I'll show you when we are doing the practical part. It is on the basis of sheer probability. So, if something is, the probability is more than 0.5, it is going to consider as a yes case. Something is below that 0.5 probability is going, even though it is 0.48. Sir, it is very marginal. No, why it can't consider? It will not consider. That is why you have to check that, how many data points are falling in that probability region, right? And you have to adjust. That is what, as a data scientist or an analyst, your job is. You have to understand the data, whether you have to push your, I can say threshold value to zero point 0.4 or zero point 0.3 or zero point 0.36 or zero point 0.38, or you have to push the threshold value up, whether it is 0.55 or 0.60 or 65, whatever it might be. So our work is to understand the data. That is why machines will not do everything. That is in what the human beings also has to be precautious when you're building a model. So that is why we do a lot of investigation, recheck on the kind of model what we have built. So obviously what will happen if the threshold value is not moved, you're just going with okay, fine, let it build zero point 0.5. So sometimes your model might perform well, and on the testing data it might not perform well also. So it is a very tedious task, and if you see the graph, maybe you can understand that it is not overfitting or underfitting. But the problem is with the threshold value. That is on where you have to see the data points where it is being actually classified. So when you test the testing accuracy, will automatically understand that this parameter tuning is very important when you actually want to play around with the threshold value and then get the right kind of output where the model is predicting something absolutely correct. Okay. So now let me just go with the data set now. Okay. So then first, I'll tell you what data set we are going to do, and then we will explain on that aspect. Okay. Right. So let me make you to understand what is an attrition rate. So I think many people already know what is an attrition rate. It is basically a person or an employee leaving an organization. That is what an attrition rate is basically about, right? So why I'm talking about the attrition rate is we are going to analyze an employee data, right? Which employee will leave the organization, that we will try to understand. How much of probability is there for a particular person to leave the organization? So that we are going to find out. We are going to test also, right? After building the model with the data set, and we'll see it on the unseen data, and we'll try to predict that how much a model is going to make sure that the person is going to stay or he's going to leave the organization. So this is what the attrition is about, right? So, these are some of the reasons you might actually come across, because, this is one of the, ideally, I can say, this is one of the huge problems when it comes to organizations. So basically, people try to, move on, right? It's not just every time, it's about salary also. There are a lot of factors also, like the voluntary resignations, and then company reconstructing, financial difficulties, shift in business strategies or focus, technological advancements, outsourcing, changing market job and workforce and demographics. So here I felt, to mention some of the reasons. Maybe people shift for money also, right? Not every time also. So there are, thousands of reasons. So if you start analyzing that, what could be the reasons? Okay. So here we are analyzing whether the person will stay or not. With the following characteristics, whether the person will stay in the organization or not. We are not trying to find the reason. We are not doing that. Okay, we are not writing a research paper to find out what could be the reasons, right? We are trying to build a model, a machine learning model, which can help us to identify that with this characteristics, if I have model with a certain data, right? I have an employee with these certain characteristics. Will my employee stay in my organization or not? That my model will tell you. That is what the main focus actually is about. Okay, so right now I'll just stop share. I'll just take up questions. I think I got a few. Is there a link between Java program? We don't have a link. Particularly data science is more focused on R and Python. particularly Python programming. Okay, unless and until you are more focused into web development and all, you're not going to use any Java in data science. Okay, and how we train? Training is done. Basically, what is training? Maybe whenever I use that particular sentence, saying that we train the algorithm. So people get confused. Training. See, what exactly is training? So training is we are teaching the machine that this is my data. Okay, so in this data, you try to find the underlying characteristics, or I can say patterns or trends, right? So you try to identify a certain patterns, trends, right? You learn from the data that what is happening in the data, right? So that is exactly what the model does. It tries to understand the variables or features, and it tries to train, understand what is happening in the data set, and it will build a certain model. Model is nothing but a representation of the data. Please understand this. So model is basically a representation of the data. So basically, if you look at the model will, will be an exact replica of what is a data set. So what is a, you can't just see the data set and if you just can't, you can't just see the data set and, say that, these kinds of things have happened in the data set. So that you cannot do. You need a certain replica or a mathematical function or a statistical function. So here we are saying it as a machine learning model. So we are building a model which represents the data set. So in simple terms, what is a model? Model is something which represents the data set. So if you look at the data set, you will not understand anything, but a model will tell you what is happening in the data set. So it is exactly opposite, but why we are building it? To make our life easy, to understand the data and make our life easy, we are going to build a model which will represent the data set. So this is the, I think a few people would have had this, a thing in the mind. So I think this actually can clear the doubt what you have. So PPT will be available. You can actually download from the LMS. So here, what is the use of attrition rate? So attrition rate is people leaving the organization, right, due to many reasons, right? So we'll try to analyze that reasons and we'll try to build a model. And with an unseen data set, we can predict whether that person will stay in the company or not. So this often happens. That is why feedback things will be collected when you leave an organization, right? So they'll be taking a feedback, right? So if you're working, you'll be understanding this. If you're not, maybe you can just imagine what I'm trying to tell you. So if you leave a particular organization, there will be a feedback form which will be collected from your HR, right? So HR will collect that why this particular person is actually leaving the organization. So that is the data what we are going to discuss. So some might get a doubt, sir. This can be biased data also. So that isn't where we have to make sure that the data doesn't get biased, right? So then only we'll be able to get an accurate results. So this is one thing we have to keep in mind. So any other questions you can just post. I'll just answer. If nobody is having anything, then I can move forward with the data set. I've shared you the link. Also, I'm sharing it again. I'm sharing it again in the group. You can download it. Okay. So let me check the. So let me check for the questions. Um, okay. I think I got one question again. How is linear different from logistic? That I already answered, Rachna. Even I've showed you also why it is or how it is different. So a simple way to understand is, the outcome is basically not a numerical value. Very simple to understand. In a very simple terms, I'll tell you. Again, okay. So since you raised this question, so linear regression, if the output is a numerical value, you can use linear regression. If the output is not numerical, right? So it's a categorical variable. You have to use the logistic regression. If I say, you have to use, that doesn't mean you have to use only logistic regression. Sometimes logistic regression might not give you a good model. You might use decision tree or a random forest or some other, SVM. So that depends upon, how you build a model. So that's why nobody builds one model and decides, yes, this is my model. No, nobody does that. People build multiple models and, check the performances, how it is actually classifying and all. So then only people get to a conclusion that yes, this model I have to use for my predictive analytics. So, if you are having any classifiers, right, any categorization or category, then you see in which condition it might fail. If the data is not particularly very linear, so not particularly very linear. And as I already told you, data, if you are really getting a data set which is very linear, right? So it is, very linear form. It is actually, it's a gift, right? It's a gift. I can say it's a boon because ideally we don't get, a data will be all, dirty, and you have to clean. Then also we have multiple problems, right? All that fixing of everything and all. Then again it has to be in a linear form. It doesn't happen actually. Very rarely I have seen data sets being linear. So most of the data sets will be definitely non-linear cases, and that is why most of the algorithms are more focused on the nonlinear aspect, particularly when it comes to neural networks. So that will be covered when we go to the neural networks part, because neural networks in deep learning, which is a part of machine learning, so that actually neural networks are basically used to cover that non-linearity only. That is why we have certain thing called as activation functions. We have layers. Each layer one activation function. Yeah, that I will discuss. I don't want to touch that now. So based on that, we build a model, right? Because data is, will not be in a smoother way. So that is one thing. So maybe this question you can understand when we, try to build models more. And I'll also show you how comparison can be done between models. So then only you'll be able to understand, rather than me showing, single model. I'll also show some comparison later. We have just started, right? So just the basics and then linear regression and now logistic regression. So we will I'll help you to understand also how to compare. So maybe yes, Shoaib, I think you can download the data set. I have already shared the link. Maybe you can just so something which is related to logistic trees ask why, because I'll be explaining each and every process in this 30 hours. This is not just a one-day session, right? So if I tell multiple things in one go, you'll get confused. So it is very difficult to take one step after the other. Okay. Can see. Yes, CDA is mandatory, Sanket. Without DDA process, you cannot do the data analysis. Yeah, exploratory data analysis is very important. So it tells you how the data is performing, how the data is, right. So basic things will be done in the EDA. Yes. So EDA is very mandatory. Yes, your question itself is the answer. EDA is very mandatory. You can add that very also in, in between. Yes. So guys, anything else before I, go into the. I'm not sure about the attendance part. So please wait till ma'am posts the attendance. Please ask me doubts regarding the subject. I'm not the right person to give you the answer for the attendance part. So, right, any other things? Just giving you a minute or so. If you don't have, we can proceed further, because first I'll explain the dataset part, and then we can move ahead with the building of the model. And we also have some interview questions to discuss also. So yeah, we have a big agenda to deal with. Fine. I think no questions, I guess. So uh, yeah, I'll come to that regularization. I'm not sure about your name. I can see Lenovo. Regularization part, I'll come to that. So see, Aishwarya. Okay, fine, Aishwarya. See, to simplify your answer, because you're asking questions which are out of which I want to discuss. Anyway, no problem. See, regularization is basically applied on the data when you have overfitting and underfitting problem. Simple. Just remember for the time being. And regularization is nothing but adding weights. Okay. So adding weights to the so if there is half mistake in your question also, because if you don't apply regularization on logistic regression, see, we apply regularization to every algorithm. Okay. So it is not just logistic regression or a linear regression, or it might be a neural networks. It doesn't matter which algorithm we are applying. That doesn't matter actually. Take out that perspective from your mind. We don't apply for one certain algorithm. Wherever we find overfitting and underfitting problem, we apply the regularization part. And this applying, how to apply this regularization, I will cover, in the coming sessions when we discuss neural networks. Right. So that is in my agenda as well. So one more question I got is uh, how ML can be used in the corporate world. So, how it is not used, right? It is used everywhere, right? One very small example, I think I've already given you, but right again, I'll be telling you that example. Maybe that will be that you can recollect. So I was just talking, when I was just, explaining logistic regression, I was telling you, huh, okay. So, when we actually want to launch a particular product, right? Just DA. It's all the same, man. It's all the same, right? It is a collective approach. So, when you very, very simple example I'm giving you, right? So you're working for a product-based company, right? Sorry. So if you're working for a product-based company, right? And your manager asks you that you have you're planning to manufacture a certain product, right? To sell it in the market. So you want to sell a particular product in the market, right? So you can't just manufacture the product and dump it in the market, right? That is not possible. So, sir, why it is not possible? Because if nobody buys, what you will do? All the research and development, everything, manufacturing cost, everything goes to waste. And one more very important aspect is why machine learning is used is you also not have to understand that which kind of product to launch, where to launch that particular product also. So in this perspective also, you need machine learning, which will give you your answer. So this machine learning will tell you, or your data analysis, whatever you are doing, will tell you that which kind of product you have to manufacture, what is the requirement of the customers, right? So what is the customer expecting if you're launching a particular product, and what are their expectations, and which price range you have to launch that particular product, and which market you have to launch that particular product. All these questions will be answered by using machine learning and data analysis. That is why we use analytics. So to answer these questions, so so ideas and all we'll talk later. Maybe discussion on the project ideas and all we will do it later. So let me make sure I explain the smaller projects first, and then we can take up yeah, we can take up on that. So I think maybe I can stop the questions part. Okay, fine. I guess I can start with the dataset. Okay, so let me share the dataset. So I think you would have already downloaded the dataset. Okay, I'm hoping you have downloaded it. Let me share. Sorry. Let me share my dataset. Okay. Yeah, that's what. I think you can see. All right. Fine. So let us see into our data set. So basically, our data set consists of multiple parameters. Okay. So a lot of parameters I have. One by one, we'll go. So coming to the first, let us walk through the data set first and try and understand that what the data set actually tells you. Okay, and what are the contents in the data set and how we can take up from there. Okay. Fine. Yeah. Now, the first column in the data set is about the age, right? So it is basically when I say employee attrition data, you can automatically understand that the first column, the age column, is basically telling you about the age of that particular employee, right? Okay. So next is attrition rate, whether that particular employee has left the organization or not. So you can see this particular person left the job, right? And this again, he left. This person have stayed. This is yes, right? So there are multiple people who have left, who are there, who are left, who are there, right? Now, like next, going to the next column. So next column tells you about the business travel. So how frequently that particular person will travel. Okay. So whether they will travel frequently or travel rarely, or they don't travel, right? So this outcome is a classifier or a categorical variable, right? Correct? No, there is not a numerical value. Here you can see age is a numerical value, right? And attrition is a categorical variable, right? Because there is a yes or a no scenario. Apart from that, there is nothing. So for business travel, you can see that there are multiple criterias. Okay, when we try to analyze, we will get what are the unique values. Yesterday, I showed how to find the unique. So you can find that whether they travel rarely, whether they travel frequently, or they don't travel, right? So all those things you can understand. So next is the daily rate. Okay, so how they charge. Okay, and then the next thing is which department they work. Okay, so you can see that which department they work. So you can see it's a sales department, research and development department, right? Again, sales. So you can see mostly sales and research development, right? So you can also see human resources here, correct? So you like that you have multiple, categories. So coming to the next part, which is, distance from home. So distance from home indicates that how much of distance that particular person travels for coming to the office. Okay, so that also plays a very important role. So continuously, no person can travel for longer distances for a longer periods of time. Okay, So next is education. So education, they have, I've divided into 4 parts, 1, 2, 3, 4. The person who is having, higher education and for example, like a, PhD or, masters, and then who is, doing graduation and so on. So like that, I have divided into categories. So next is the next part is which education field they are into. So here you can see life sciences, others, life sciences, medical, all those things we have. Okay, so medical, life sciences, and then technical degree, right? Like this, we have multiple parameters. And then you can see that, okay, you have one more column, which is employee count. So obviously this will be 1. Okay. So I think this column is not that important for us, correct? No? Yeah. So next is employee number. So this is the number of the employee in that particular organization. So this is also not very important for us, correct? No, logically, if we think employee count and employee number, what we will do? Nothing we can do, correct? No. Next is employee, what is this? Employee satisfaction. So whether that employee, it is divided into 4 levels again. So whether that employee is satisfied or dissatisfied, right? So you can get the data. So again, some people might get doubt where, whether he's really telling the data. So that is in where we have to make sure whether, we are collecting the data, whether the data is, the employee is telling correctly or not, we have to find out. Okay. So that is one important thing which is in our hand. Okay. So next column is the gender, where you can see whether it is a male or a female. So again, here 2 categories, right? 2 classifiers, whether it is a male or a female. So 2 categories. So categorical outcome again. Education field is also a categorical outcome. Department is also a categorical outcome, right? Distance from home, education. Education is also categorical, right? So this is already, it's given on a level, it is an ordinal scale, 1, 2, 3, 4. Okay, employee count and employee number, don't bother because anyway we'll remove that particular columns. So employee satisfaction level is again a categorical. We have given encoding for this. So next is whether the person is male or a female, so gender, and then hourly rate, right? So this is the daily rate what that particular person gets, and hourly rate is what the person gets per hour. So next thing is job involvement. Again, here so here again in job involvement, we are giving the levels 1, 2, 3, 4. It's again a categorical output. Whether the person is involved so much, whether the person is not that involved, like that, we are dividing into 4 categories. Next is the job level. So, which level they are in. Okay. So here also again, 4 categories. So particularly, 4th level will be your manager. You can see here. So job role, you can see that that particular, person. I'll just move this. Yeah. So that particular person, he's in which kind of role. So lab, generally the level 1 will be the technicians, right? Level 2 will be the representatives, and level 3 will be the manufacturing direct manufacturing that level. Even we have level 5 also, which is manager level and all those things. Okay. So level 4, level 5, manager level. Then we have the next part, which is the job satisfaction, right? So how much of job satisfaction is there for that particular employee? Okay. So he's working from long or a long time. It doesn't mean whether he's, he's satisfied or not. So next thing is again marital status. This is again categorical. So whether he's single, married, divorced, right? I think only 3 will get, right? Single, married, and divorced. Yeah. So single, married, divorced. I think only 3 categories we will be getting. Okay, so next is monthly income. So how much this person is actually getting per month. Okay, so next is monthly rate. Okay, so how much he is getting per month extra. Okay, and then we have what is this? Number of companies worked previously. So how many companies he has worked, right? So 1 companies, you can see 1 company, 6 companies, 8 companies, 9 companies, and so on, right? So you can see again over 18. I think this column is also not that useful. Maybe we can take out also. So overtime, whether they have done overtime or not. right? Yes or a no scenario. And then we have the percent salary hike, what they got previously, how much of salary hike they would have got. And then the next thing is, performance rating. So how much of rating they would have got, right? So now you're looking at this data, you'll be wondering, such a huge data we have to analyze. Yes, we have to analyze because our data will be like this only. So our data will be very huge. Our data will be actually very huge. So, you might have 30 parameters or 30, variables or, 40 variables and so on. So we have to analyze each and every variable. Whatever is not important, anyway, we are going to remove that. So performance rating, the last performance rating you can say. So relationship satisfaction. So this is also they have collected from the person. So that means whether they are satisfied or not that satisfied because this person is single. So first level might be he's satisfied. Okay. So the level of satisfaction, maybe this person is married. So he's in the fourth level. So next is the standard hours, how many standard hours he works. I think I can see 80 here. Maybe everybody has to work 80, right? And then maybe if I go down, maybe it might become less or it might become more. I'm not sure. That we will analyze, right? We will not just scroll and check for whatever is there. Let us not scroll. So let us analyze and then understand. So next is stock option available. Whether that particular person, whether he will total training years. Let me see. Just let me move this. Yeah. So how many trainings he has given, work-life balance, levels of satisfaction, years at the company, right? So I think this stock option is, whether he is, which level he is actually taking care of that particular stocks in the company. So let me move total years. Yeah, training time last year, work-life balance, year at the company. And then it comes to the years in the current role. So how many years he is in the current role. So that also leads to the dissatisfaction also, right? So if you're too many in that particular role without a promotion also, people might leave the organization. So that is also actually years in current role is very important as per, work-life balance and years of company. These things play a very important role. So years since the last promotion. So how many years it's been that, since last he got promotion. So next is, you know, then, yeah, in current role, last promotion, and then the last column is years with the current manager. So how many years he's been with the current manager. So because sometimes if the manager is same and he's not also in the same role. So this we will analyze, right? We cannot come to a conclusion just by looking at the data. That is why we try to do the analysis part, trying to understand the data set. So this is what is about the data set. Okay. So let us go into the Python coding. Okay, and try and understand that how we can analyze the data set. Let me check any questions. Questions. Okay, I think none. Uh, oh yes, you can do it in the Python coding. Yes. So Anaconda, yes. Yeah. Yeah, sure. Sure. We'll provide. Let me start with this. Okay. So that is about the data set. Let us try and understand what is happening in the data set now. Okay. So when we try to analyze what are the facts which we are going to know. Okay, let me share my screen. Yeah. Okay. So let us take it slow. Okay. The first important thing is importing the necessary libraries. I think you can see my screen. Okay, fine. Maybe I can, yeah, do. Okay. So right. So let us first try and understand the first step in our journey of this applying of this logistic regression. So the most important part is importing the libraries. So what are these libraries which we have to import? So yesterday we have seen some of the libraries like pandas, numpy, seaborn, matplotlib, right? This we have seen. So we use pandas as PD. So importing pandas as PD, then numpy as NP, and seaborn as SNS, and matplotlib as PLT, which is .pyplot. So this also we have seen, which is sklearn, right? This also we have seen because when we have done the linear regression, we have applied the training and testing, right? So, splitting the data into training and testing, that will be done for every algorithm. So that is a common syntax again, if you use linear logistic or, even use decision trees and so on. So any kind of algorithm, you are going to use this function, which is sklearn.model selection. So model underscore selection is a function, sorry, it's a module under sklearn, and the function is training and testing. All right. So that splitting we have to use. So next thing is for pre-processing, we are going to use the standard scalar, right? So scalar, we have already discussed about the standard scalar. So next is the linear model, which is so this logistic regression is part of linear model function only. Okay. It is part of linear underscore model module. Okay. So it will be inside the linear underscore model module, right? So we have to import the logistic regression part. Okay, that is the function which we are going to apply. So next is the next important thing is three very important metrics we are going to import. So here the function which we are going to use, or I can say the library and the module which we are going to use is the sklearn.metrics. Now there will be a little doubt in some people's mind. So yesterday when we have done linear regression, we have imported the mean square error and the R square, right? So why we have imported that? Because for it those metrics are used for the numerical uh, you know if the output is a numerical value, we are going to use that particular metrics to evaluate. So if the outcome is a classifier, right? So, or whether it is a classification problem, right? So we have to use the metrics, right? Such as classification report, confusion matrix, accuracy score. We cannot use R square and mean square error. So this is one small thing you have to remember when you pull in. So if I mention mean square error, R square, anything else, nothing will happen, right? But you will not use that particular code anywhere in that coding part which you use. So why to import libraries which are not required? Okay, unnecessary space waste, not required, right? So not required to import. So whatever is important for your project, you can only include those particular things. So whatever is required, sometimes you'll be already knowing in advance, right? That comes through practice. So if you don't know what to import, maybe through the process when you are doing that particular when you are doing that particular project, right, step by step, you may or you may come across a particular library or a module which you have not imported, so that you can import. So all the importing things you can put it at the top. Okay, so why to put at the top is it looks very neat and decent, and it is very easy to understand that you have imported all these libraries and modules and functions. So, or else what happens is, if you put middle, maybe while doing, you can put in the middle and then you can, pull all those things at the top. So it will be clear that, okay, this is what you have used for doing this project or for building this project. So this is what is very important when you actually do a certain project. So now let us go to the data set. So already the data set I've shared with you, which is the employee attrition data.csv, right? So it's a comma separated file value. So that is what CSV basically is. Okay. So how to read a file? I've already showed you yesterday, which is pt.read_csv. So pt.read_csv is the syntax which is used to read the dataset. So going to the next part. So I think till here everybody is clear. That's what I feel. So anything you have any doubt regarding that, you can ask me. No, you have to mention Excel SX. That is a format for reading in Excel form. Excel file will not have an extension for Excel. The CSV is also an Excel file only, Aishwarya. So it's, yeah, you have to see, you have to right click your if you right click your Excel file, yes, if you go to the properties, you can see the properties what your Excel file is having. So if it is Excel SX, you can change it to Excel SX. Usually your data sets will be in the format, will be in the form of CSV, because they have to mention multiple columns and all. So usually the data will be prepared in the form of CSV. So you have to give read_CSV. Yeah. Yes. Yeah. I think that is cleared, I guess. So anything else? Please check the spelling, Professor. You have mentioned standard salar, not it is standard scalar. Yeah. So even a small spelling mistake will be, yeah, even the dot, the module name, what you mentioned is, mistake, everything, it will push out an error. So it should be perfectly fine if you have to, uh, you know, yeah. I've pasted it. And the address also, you can put whatever address is of your laptop. So whatever address is you are using, that you can mention. Is there another library? No. For machine learning, we use scikit-learn. There is only one library. So we call it as scikit-learn. But when you write as a coding part, you say it as sklearn. Okay. Yes. So you can actually use the the coding part what I've shared. In pt.read_csv, you can actually change the address of your laptop or a computer, whatever wherever you have downloaded the data set. That address you have to give. Please do not give my address and say there's an error coming. Okay, so this is my address. I'm having trouble in IP. Like, uh, maybe you can use Google Colab if you don't have Jupyter. If you don't have Anaconda Navigator, if you have not installed and you don't want to install Anaconda, maybe you can go with the cloud-based. You can go with the cloud-based, which is Google Colab. That is fine. I already told you you can use Google Colab if you don't want to install, because Colab you need not install any software. Directly you can open in Google, you can search for Google Colab. It will be it will come. The only thing is you have to log in with your Gmail account. Yes, you can use Collab. That should be fine. So, one more advantage also, I told you yesterday this, again, I'm telling you. If you use Collab, you need not install any libraries. For example, if you're using Jupyter, right, like what I'm using. So if you don't want, if you want to use scikit-learn, you have to install this scikit-learn, right? You have to use the pip install scikit-learn. But if you use Collab, you need not install any software. So automatically it will work. So that is one advantage you can have. So you can use Collab. I would guess, I would feel that will be better for many people. If if you want to use the coding part without installing anything. Okay. So maybe I can yeah. So just give me a minute. I'll just show you the Collab. I'll just show you the Collab. Maybe you can use it. Let me share the Collab also. I've just opened it. Maybe you can use that also if you want. Yeah. So you'll get the Collab like this if you want to use Collab. So you can take a new page of Collab and you can use it. Huh. Yes, that's what I was just opening to show you guys. But there is one important thing when it comes to Collab. Let me take this code and let me run. I'll show you something, right? So you can paste the code like this. Okay. And once you paste, you can click on this run symbol. It will run, it will execute. So once it is executed, you will get a tick mark. So you can see that it is executing line by line. So you'll get a tick mark. Okay. And it will not create a line on its own. You have to click on this line code. Okay. And one more important thing is you cannot use the syntax what I have given here. For example, pd.read_csv you cannot do. What you have to do is you have to go to this files. You have to import the data. Here you can see that upload the data, upload symbol. Yeah, you have to upload that data and you have to, yeah, you have to import that data, right? That is there that is for Jupyter. You can use Shift Enter, Aishwarya. That will work. Yeah. No, but I just wanted to show you that this symbol exists for execution. Yes. So that is why I'm showing that. Yes. Ah, okay. So let me shift back to Jupyter. Okay. So maybe if you want, I can show it in both, but I don't think it will. I can't. It takes a lot of time for me to show in both. It's the same, very few differences are there from Jupyter to Google Colab. That small things you have to adapt. Apart from that, I don't think there's much difference. The compilation and all is good. I feel this, Jupyter is tad bit faster in compilation than Colab. So what do you prefer? I use Jupyter once in a while. I use Google Colab also to for trainings and if people want to work in collab, I shift to collab also. That is completely optional. Yeah. So I cannot justify, but most of my projects, I do it in Jupyter. I like, kindly personally, I have a biased opinion on Jupyter. So maybe, so it's like that. Yeah. So let us not waste time on that. Let me go to the project part. Let me share my screen. Yeah. Yeah, I think it's good to go. Fine. So this is in where once we imported the libraries part, so we read the data set. Okay. So we read the data set and we get the data set, right? So we give this address, whatever address you have, and you get the output. Now let us go to the next part, which is the data overview. So as you already know from yesterday that we have a function called as head function. So df.head, right? So here you can see that the function is basically, or the function will basically give you the first 5 observations of that particular columns. Okay. So it will give the first 5 observations in the data set. So tail will give you the top 5. Okay. So now let us go to the next part, which is df.info. Okay. So if you use df.info, info gives you the information about the data set. Okay. The first is I think yeah, this one I pasted. Yes. So this also I'll paste. Yeah. So head function gives the head, and let me go to the info. Okay. So info function basically gives the particularly this is used to identify any null values are existing. Okay. So anything which has some null values. So here you can see that all the data points are existing. So 1470 data are there. In totally we have 35 columns or features because it starts with 0, right? So it starts from 0 to 34. So it is total of 35 features or attributes or columns, right? So next, and one more thing is here you can see whether there is any null value in that particular column or not. So you can see there is no null value in each column, right? So all the values are not null, right? Or non-null values. And one more thing is here you can see the data type of that particular feature or column. So if something is in the form of an numerical value, feature is column, yes. So columns we call it as features, yes. Rows we call it as records, yes. So yeah, so here you can see that something which is age is a numerical value, so it shows an integer. Okay, so something which is a categorical value, attrition, whether it is yes or no, right? So it shows as an object. Okay, so integer or object it will show, right? So let us go forward on this. Next is the describe function. So basically describe function gives the it describes the data. Okay, that's why we are calling it as a describe function. So what it does is it will give you the count. And one more thing I already told you, it actually, wherever it sees the numerical value, it will calculate. Okay, but here one problem is there. Here you have seen that some of the values we have we have uh, I can say we have changed it to scale 1, 2, 3, 4. So that particular columns you cannot consider. Best example is education. How you can classify education, right? What is this education? 1.0, 2.9, right? Because we have classified it to one, scale of 1 to 4. It is calculating because it found that it is a numerical value and it started calculating. So I'll tell you for what columns we can, age, right? We can use the describe function. Daily rate we can use. Distance from home we can use. Education you cannot use. Employee count you cannot use. Employee number you cannot use. Employee satisfaction you cannot use. Hourly rate you can use. Job involvement you cannot use. Job level you cannot use. Relationship satisfaction you cannot use. Standard hours you can use. So anyway, this is all 80 only, most probably. Minimum, maximum, yeah, I can see 80. So this column itself is not required. You can, you can just delete it. And then we have stock optional level also, we cannot, no need. So total working years, this we can, use this mean, standard deviation, quartiles, and percentile and all. So this we can use, right? So training times last year, also we can use, yes. So years in the current role, yes, we can use, it's a numerical thing only. It's not a categorical. So years at the company is also useful. Work-life balance, I don't think this is also useful. I think it is just 1 to 4. Yeah. So this work-life balance thing is also not used, not required. Then years since last promotion also, yeah, this is also required because the data is a numerical value. Years with the current manager is also very important because that is also a numerical value. So we have to, because some we have given as a we have already encoded it or we have given it on a scale. So since we have already given it on a scale, that doesn't make sense to calculate, right? But since it has picked as a numerical value, so or you have to mention that, which columns you want to create. That is again, I feel, we know our data, no? Why you want again, to give. So if you manually want to give, you can give that only these columns you can give the describe function. In that bracket you can mention which columns you want to, here you can mention age, right? Yeah, so whatever you want you can mention there, those particular columns only it will give you. No sir, fine, let it give everything. We will see that which are required for us and we will take. Fine, that is also fine, or whatever you want you can give. So anything is up to the person who is doing the analysis. Okay, because this coding part and all we will not show to the the client, right? This is all internal coding what we actually do. So next is the data pre-processing part, and anyway this first step is basically we don't require anyway because we know that there are no null values, right? So something, if any null values are existing in your data, you can actually use this is null function. So always remember is null is the function which will calculate the null values inside the data set. Okay, so no, attendance is not taken. Please, yeah, you will get the attendance shortly. Please wait. Okay, so isNull is the function where it will calculate or check the null values in the particular, column. Then this dot sum function will sum the null values, whatever are there. So, never just give df dot is null. So what will happen is it will create a table showing, true, false, true, false, true, false. How many, if the data is in lakhs, you will sit and count, right? Will not count, right? So that is why I always remember, never forget to give the function is along with is null, never forget to give the function dot sum. So it will only sum all the null values wherever, for example, age has any, you can see any 4 null values. It will give 4. That means 4 rows are empty in age. So gender, maybe some 2 or 3 are empty. It will give 2 or 3, whatever is empty. So always remember, very small function and a very small thing. Always remember to give is dot sum when you are giving the is null function. So going to the next part, we are going to encode the variables, right? So what we are trying to encode is basically, let me copy the code and give it to you. Yeah. So now what exactly we are trying to encode here is, we are trying to give wherever you can see yes as 1 and wherever we can see no as 0. So that we are going to give for which column we are giving it for attrition. You can see that for attrition, we are mapping or we are allocating wherever you can find as yes, please give as 1, and wherever you see as 0, we are giving there. Wherever you are seeing no, you are giving as 0. Okay. The same thing we are doing it for gender. The second line is that only. So we are giving it for gender. So here again, male is 1 and female is 0. That is what we are giving. Okay. Now, next thing is we are creating a particular dummy columns, right? So now what exactly we are trying to do is, if you see, there are certain parameters. Okay. So for example, like, travel time, okay, department, education, job role, these and all are not required. Okay. So we are basically, right, we are basically dropping that particular columns, okay, which are not required. Why does it matter what is his marital status? Not required. Which department he is? No, not required. Leave. It doesn't matter whether the person, tell me whether he's staying or not. That's it. That is my way of understanding, right? So now the client also wants that only. He doesn't want to listen to you what, you want, what analysis you are trying to do, right? So next, let us, without any further delay, let us go, into building or dividing whatever important features are there and what are the important features we are going to take for an analysis. So anyway, now you know that obviously our outcome variable or a target variable is basically attrition, right? So here you're trying to understand that your outcome is an attrition. So we are taking the outcome variable, which is the y variable, which is a dependent variable. So this dependent variable y becomes a, right, it becomes a outcome variable or a target variable. Now here we have a lot of features or a lot of, right, lot of input variables, right? So what we are going to do is we are picking the important features, what is required for us in our analysis. So one such important thing is the age, the job satisfaction, the monthly income, right? And then years at the company, and then gender, right? Total working years, number of companies worked, and overtime, whether it is yes or not. Okay. So I'm just considering whatever is yes. Okay. So now those particular employees or those particular data, I'm taking it as X, which is the input variable. Now I am dividing it into two. Now the next important thing is using the standard scalar. So this standard scalar scales the values, right? And it will scale and it will transform or fit into the data, right? That is why we are using the standard scalar or feature scalar. So this one feature scaling, what we are actually trying to do. So this one yesterday, even for linear regression, we have done. So the function is basically the fit underscore transform is the function. Okay. So this fit is nothing but you are asking the compiler to fit in that X values. What are those X values? Which are the features what we have taken here, right? So it asks to fit. That means please do scaling, right? That means normalization for that particular columns, what I have given here as a X variable or an input variable. That is what this is. So next important thing is after feature scaling, the important thing what we are going to do is the four important parts. The same thing what we have done. This is a very standard syntax. Already I told you yesterday. So this is a syntax where we divide the data into four parts. One is xtrain, xtest, ytrain, and ytest. So in x value, which is the independent variable, we have two parts, which is the training data and testing data. So we give it as xtrain and xtest. And again for dependent variable, which is y, we are going to give as ytrain and ytest. Okay. And we use the function where in the pre-processing at the starting we have used now, right? So for model selection, right? If you go up, maybe you can remember. I'll just scroll it up for your see. For model selection, you have given no train underscore test underscore split. That same function you are going to use down. So whatever is required there only we will give whatever functions we require. So train underscore test underscore split is the function which we are going to use. And we are going to use the variable x scaled, right? Because we have used the scalar to scale the variables or the values of x. Okay. Okay, fine. So here, once you have put the scaled values, then you have given the dependent value, and then we are giving the test size. So I already told you that, if you are giving the test size as 0.3, that means the testing size is 30%. So if the testing size is 30%, the training data will be 70%. Okay. And random state is this is for random seeding, which is a fixed value, which will fix that particular, random seeding, what is actually done. So next, coming to the function, which is, I think I've shared this, fit scalar and share this one also. Okay, great. So next function is fitting the model for the logistic regression. So it's a very important thing is we use the log model. Okay, you can use any variable, it doesn't matter. We define the logistic, sorry, we define the logistic regression and we use the function dot fit. See carefully, we are fitting the logistic regression for the training variables, which is X train and Y train. We are not going to fit it for the X test and the Y test, because we have to test on that after the model has been built. Okay, so we cannot give X test and correct. No, we cannot give the on the X test, right? We only will be giving for prediction. Okay, so here first, to fit the logistic regression model, we give only the training and the training data, which is either it is X, right? It is both for X and Y. So the function is dot fit X train and Y train. Okay, so fit function will automatically fit here. Log model is nothing but the logistic regression model. So this is the same thing, you can give it here also. So we are fitting the logistic regression part. Okay. Yeah, I've shared it. So we are fitting the logistic regression part, and you're defining that particular part for the variables, which is X train and Y train. Okay. Now let me go down. After doing that, we are trying to evaluate the model by giving the log model. Okay, by giving the model which is used for prediction. So now what is the logistic regression? Log model is nothing but what is log model? You can see here, which is the logistic regression. So to give on both, that's why we have defined here. Sir, do we need to define like this? No, you're not required. You can directly give logistic regression dot fit and X train and Y train, or you can automate, or you can give directly, or you can define a variable and you can give. Anything is fine, not a problem. And when you try to make a prediction on the testing variable, right? And then we start to build on the confusion matrix, which will give you. Okay. Yeah. So nowadays, this confusion matrix, there are, some flaws where you can, see, you can try it in, Google Colab, right? Sometimes it is not filling all the values. For example, even the correlation matrix I've observed. So maybe you can try, in Colab for that. Okay. Very recently, this problem has started, particularly in for correlation as well as confusion matrix. Maybe you can check on that in Google Colab. Okay. So now if you see that when you have done the prediction part, okay, once you have done the prediction part, you build the confusion matrix. So confusion matrix will give you the yesterday, when I've in linear regression, we cannot implement confusion matrix. So that is the reason I have not implemented and showed you. But when we have discussed, I showed you that what is the confusion matrix. So confusion matrix is nothing but a matrix which gives you the true positive, false positive, true negative, and false negative things inside the matrix. So here we are giving some colors and all we can give, which will give you the predicted value, or you can say the tested value for Y as well as the predicted value. Okay. Now after building the confusion matrix, let me go down, and here the very important thing is the classification report. Okay, this is very important. So what is this classification? What is this classification report? Basically will tell you is, this classification report will tell you that how much the values are actually predicted correctly. Okay, and you can see the accuracy. So the accuracy is around 85%. Okay, so I've asked to calculate the accuracy in percentage. That is why it has given me as a percentage. Okay, if you want to give like this, you can give. So what it will do is it will show you the number of predictions correctly predicted. For example, for the value 0, that means there is no attrition, right? The precision is 87%, right? And recall is 97%. Okay, and F1 score is basically the harmonic mean of both precision and recall. So here you can see that there is a 92% of accuracy. And when it comes to the prediction of ones, which is they're having, whether they are having attrition or not, you can see that 35% of precision and recall is 10%. So and the F1 score has come down because of the recall, right? So it becomes 15%, and the support indicates the number of uh, records which is supporting, or rows which are supporting. So for one, the support is 61. So there is only 61 support. That is the problem, major problem here. And for zeros, it is basically 380. Okay. So for the the actually, I think there's a imbalance in the data set also. Okay. So that we will fix in the EDA process and all those things. So here the support, and for zeros and ones, there's a lot of gap between the support part. Okay, so that is why even our accuracy has come down, or else our accuracy would have been above 90% or something like that. So some tuning of parameters is required for this particular project to achieve, because we can achieve even more accuracy when we tune the parameters correctly and we try to build the model. Now, next, going to the importance, what are the important features? So here, the most important thing is which feature is playing a very important role. So for example, higher the positive is, it's playing a very important role. For example, like overtime, right? So overtime is playing a very important role, and the number of companies. We can, yeah. I was just predicting this kind of question. You cannot simply remove the data. Okay, you cannot simply remove the data. We use a technique called SMOT. SMOT, SMOTE. So this SMOT technique is basically, is basically about handling the imbalance in the data. So it will, create duplicates. If the data is, wherever less is there, it will create duplicates. If more is there, it will try to reduce. It will try to sample and reduce. We use the SMOT technique. Definitely, I will cover the SMOT technique also, right? How the model uses the SMOT. This is because good thing, because that is one important thing which is which has to be done. We cannot simply keep on removing the values. We cannot handle like that. That is not a proper way of dealing it. So yes. So let me copy this. So basically, this feature importance give you the important features which are mostly contributing to the outcome variable. Okay, and I've posted this code. Yes. So next thing is, let us go to the unseen data point. Okay, so let me go to the unseen data point. Okay, so now, if I want to check, okay, if I want to check that, right? So whether the particular person what I've passed the data, right? So whether that particular person, right, will have attrition or not, because I've built a model, right? Some 85% accuracy, I've built a model. Now, if I pass that data point, for example, my data point consists of that person having an age of 35. You can see here. This is my data, what I've passed. So if I see that the person is having an age 35 and that job satisfaction is level 4, okay, and work this too. And does he do overtime? Yes, he does. Now the data, whatever we have given, the same thing we have to make it a, we have to transform, we have to build it as a scalar. Okay, Okay, so a lot of questions here. Yeah, maybe I'll take up a questions. Please just wait. Yes, please wait, guys. Almost finishing this. I'll come to the questions part. Okay. Huh. So here, if you see that, you have to transform the data what you have given also, right? So we'll apply the transformation here. Okay, and then we will make the prediction part. So here you can see that you are making a prediction. Okay, so here if you see that defaultly we have not mentioned any threshold value. So defaultly it will take as threshold value as zero point 0.5. Now when you calculate, I'm getting a probability of 0.74. So I'm getting this probability for 0.74 for, for I can say no attrition, right? That the person will stay in the organization, right? Because attrition is people leaving. No attrition means the person is staying in the organization. So 0.749 probability I got. So around 75%, my model says around 75% probability is there that a person will stay in the organization. And my 25%, the model says that the person will not stay in the organization. Okay, so now based on this, it is about zero point 0.5, right? That means the model will consider that it is a yes case, right? Since I also wanted to print the probabilities, that is the reason I printed the probabilities. Usually you will not print any probabilities, but if you want to see, I just wanted to show you as well that how much of probability is there for when you are predicting whether the point is the no attrition is having how much of probability, and attrition is showing how much of probability. So in that case, that is why I've just showed the probability for both as well, so around 75 and 25. So now since the data point is above that zero point 0.5 level of it's above that zero point 0.5, right? So what happens is it will take it as a yes case. That means there is no attrition, right? So it is giving that the person who you passed and you're asking to predict using the model, right? It is no attrition. That means the person is going to stay in the organization. So this is what the analysis we can, or this is what you can understand from building a model. So you can predict like this after you build a model. So this is the part. I think I've shared this also code. Yes, I've shared. So this is what the model is about. Okay, let me stop sharing the screen. Let me just take the questions. I think many questions people have, since I'm in the middle of explanation of the project, I didn't take up the questions. Let me go to the questions part. So let me go to the questions, guys. Attendance part, I already told you. Uh, it's about logistic regression. Okay, guys. So it's not logistics, it is logistic. Okay, maybe you can never call it as logistics. Okay, it is logistic regression. It's not continuation of yesterday's class. Yesterday it was linear regression. Today it is logistic regression. Completely different algorithms. Maybe you got confused with the word regression. Okay, so yeah, that word might create a confusion. Okay, yeah, it's about the attrition rate. Yes. For linear regression, yes, I can share. I think I've shared the IP1 file. Maybe I can just give me a minute. Yes, yes, just give me a minute, please. Uh, yeah, I'll share to the LMS. Maybe IP1 file I can give it to you. I don't know how you can import. Just give me a minute. House price prediction. You can share. Just give me a minute. I'll make sure it is available. I'll just inform the team. Yeah. Yeah, I think I'm able to share this IPv4 file. Yes. Yes, I'm able to share here actually. Maybe you can download that IPv4 file. Just give me a minute. So this IPv4 file for employee attrition, what we have done also, I'll share you the IPv4 file. So in Jupyter, you can just have upload and you can use that IPv4 file. I think that will be helpful for you. Yeah, I've shared both now again. Employee attrition rate as well as for the house price prediction. Yes. So anything, any doubts if you have, maybe next session we can do some interview questions. That is what I felt. This logistic regression took a little time. Do also analyze and process data the way we do and do use Jupyter. Yes, they use, but I can say some of the companies use Azure ML. Okay, so why? Because they do it in the cloud. Okay, so they do it in the cloud. They use Azure ML. The only difference what you will find when you are doing in Jupyter Notebook and you go to the corporates where you can see in Azure ML, the only difference just little, even the syntax doesn't vary much. Only the libraries what you call, the way you use changes. So it is like very small example and tell you that you can understand like this. Maybe MySQL and SQL Server. For example, if you learn MySQL, right, SQL Server is almost the same. So around 80-85% of SQL Server, from MySQL only, SQL Server will be there. So that minor changes you have to adapt. So that the small changes that you can adopt, so it will be fine. Yeah. So it might be Azure ML or it might be PySpark. So it is multiple platforms. So that is why you have something called as a training in our organizations. So they train you on that particular platform, what they are doing. See, 100 companies use 100 platforms. You cannot sit and learn 100 platforms. That is not possible. That is why we learn a common platform and we try to build the basics, right? We try to build the basics on what we are going to do. Okay. So once we build the basics on the concepts of how to implement and all those things, the small changes what you see in the companies, you can learn in that training period. This is what you can actually do. So because don't run trying to learn multiple things, right? There are hundreds of platforms where you can implement Python, but I use only Collab, and I use even I used to use Visual Studio before, but very rarely I'm using it now. Most more focus, I'll put it on Jupyter Notebook and Google Colab. So yeah, and in the cloud I'll do anyway on Azure ML. So that is a different story. Yeah. So that is for my projects and all. This is for explanation and all those things. I don't use that Azure ML. Yes. So it is different. That I will tell you. that is not now. Deployment part will come in the coming sessions. So it's only day 3. We have many algorithms to discuss first, maybe for another 5 days or another 10 hours, and then comes the deployment part and project capstone project and all that comes a little later. You can just be patient. Thank you. So you can just be patient and you can. No, we don't have. I think ma'am will announce. We only have on weekdays. Yeah. So anything else, guys? Please ask if you have any questions. Maybe you can clear it off. Because while I'm explaining in the middle, I can't take questions. So it's very difficult to the flow will be missed. So that is why I just wait. Once I finish, then we can have the discussion on questions. So let me check the chat again. So any PDF. I'm not shared any PDF. It is not PDF. It is IPY. It is IPY NB file. Why is removing the data is bad to balance the data? If you don't remove it, I'm not sure about your name, but we don't remove it like that. The most important thing is balancing the data. So if the data is not balanced, we have an unbalanced data set. We balance it out by using the smart techniques. That is what I was telling you. I'll explain those techniques as well. Yeah. So we don't just simply, because we might lose some important information if we just keep on deleting the data to balance it. The files what I've shared, IPYNB files, it is not PDF. Uh, you have to go to the Jupyter and then you have to. Okay, so this question is out of the thing what we are discussing. So random forest is nothing but a collection of decision trees. We'll do that, madam. Samiksha, yes. So next session we are going to do that. Some interview questions we have to discuss on what we have done. It is very important because the main focus is on the interview questions as well. How the questions will be formed in the corporates while asking this machine learning part. So we'll cover that interview questions part, and we'll go into the decision trees and random forest. I'll train you on that also. I'll help you guide on that. So random forest is not a new concept. It is actually a collection of decision trees. So if you understand decision trees, the random forest will be very easy. Yes, using from mobile. Okay, that's why I've suggested to use a laptop. You can download it in laptop. Fine, I'll share. I'll share. You can use it. I'll inform them. So anybody, anything else? Any questions? Yeah. So I think uh, what are the assumptions of linear regression while doing a project? So this one I think I've not answered maybe. Assumptions of linear regression I've already discussed. So data should be linear, right? The output should be a numerical value. Like that, we have many assumptions. I've already discussed Mahi yesterday. What is SVM? Okay, I think your question is here. So SVM is again support vector machines, ma'am. It is again mostly used for classification. So I'll cover SVM also in our coming session, because without SVM there is no ML. So that much important even this, SPM is. So linear regression, logistic regression, naive-Bayes algorithm, decision trees, random forest, SVM, these are very important, including the neural networks. So this part I will cover along with the project explanations and how to use the data set for predicting and all that I'll cover anyway. It's only day 3, so we have a lot of sessions and the 12 days. Yeah, so there's a lot. Yes, there's a lot to discuss and a lot of things to do as well. Yes. So if you guys don't have questions, maybe we can wind it up. So I think done. Maybe I'll just recheck with the questions first. I think it's nothing else is there. Okay, so ma'am, you can end it up, Shushmita ma'am.
Yeah, sure, sir.
Yes.
Yeah. So, like, as you all know, like tomorrow and day after tomorrow, that will be Saturday and Sunday. We don't have any session. We'll meeting again on Monday at 7 p.m. So, thank you, sir. Thank you so much for your valuable class.
Yes.
Yeah, thank you. So, students, thank you for joining today's session. We'll meet again by tomorrow. Sorry, on Monday. Thank you all. Good night.